Hi everyone, this is Dr. Meadows, and in this video we will find probabilities and proportions as areas under the normal curve. Specifically, this video is about using Excel to do just that. First, we'll work with an exercise that has to do with Air Force pilots. We want to assume that women's heights are normally distributed with a mean of 63.8 inches and a standard deviation of 2.6. I'll label those. As you can see, I labeled the mean using the Greek letter mu and the standard deviation using the Greek letter sigma. We're told that the U.S. Air Force requires that pilots have heights between 64 inches and 77 inches. We want to, for Part A, find the percentage of women who are shorter than 64 inches. In other words, we're looking for the probability that X is less than 64. Now let's remember that the average, or the mean, is 63.8 inches. That sits right in the middle of our normal distribution. We are asked to find the probability that X is less than 64. Well, if we first locate 64 on the normal distribution graph on the axes, we'll see that it is slightly to the right of 63.8. Now, the problem asked us to actually find the probability that X is less than 64. That's the same as the percentage that we're looking for, and it is the area to the left of 64 and under this curve. Okay. Now let's use Excel to actually find this area. And as you can see, I've already prepared our norm.dis command. So the command here is the command that we will use. Let's go ahead and type it in. Now that we've chosen norm.dis, first thing it asks us to enter is the X value. Well, the X value that we're interested in is 64. Next, it asks us for the mean, and I've taken the liberty of doing some note-taking, and the mean and the standard deviation are already listed above. I'll click on those. The next value that we enter is the cumulative, and for us, in a norm.dis situation, this will always be 1. Now, we have found the area to the left, because this norm.dist command actually gives us the area to the left of a particular X value. So, let's go ahead and label that area under the graph. Okay, please don't forget that there is a difference, a big difference, between the areas under the graph and the values that we see on the axes. So we see the mean and our value of 64 labeled on the axes. But the area under the graph is approximately 0.5307. So the percentage of women who are shorter than 64 inches is approximately 0.5307. Now, let's move to the same type situation, but a different question. For Part B, we're asked to find the percentage of women who are taller than 70 inches. Once again, our mean is 63.8, which is here. I don't know exactly where 70 is, but I'll locate 70 to the right for sure of 63.8. Now this question actually is asking us to find the percentage of women who are taller than 70 inches. In other words, we want to find the probability that X is greater than 70. I'll shade the area. Please be aware that our norm.dist function only gives us the area to the left. However, if we know the area to the left under a normal curve, then we can easily find the area to the right. Let's not forget that the total area under a standard normal curve is 1. If the total area under the curve is 1, then the area to the right must be 1 minus the area to the left. Therefore, you see that our Excel formula for this situation is slightly different. We will consider 1 minus norm.dist, remembering that norm.dist gives us the area to the left. Let's go ahead and calculate this area using Excel. Once again, we are first asked to enter the value of x, so I'll type in the 70. The mean and the standard deviation are the same as the problem above, and we'll click on those. And once again, we will enter the cumulative of 1. Okay, and so we can see that's a very small area. The area to the right of 70 is 0.0085 approximately. I can't write up under the curve with it being so small, so I'll simply write the probability and point to the area. Okay, so that's how we find the area to the right in a normal distribution. Let's now look at a problem where we actually want to find the area in between two data values. Part C says find the percentage of women meeting the height requirement. Well, let's remind ourselves that the U.S. Air Force requires the pilots have heights between 64 and 77 inches. Let's label that on the normal curve. Okay, so now I've also written to remind us that the mean is 63.8 and it sits in the middle. The mean is listed in purple. However, our data values that we're interested in are listed in red, and we want to find the area in between. Let's write this as a probability. So now you see that the area we shaded is the same as the probability that x is between 64 and 77. This is a correction. So let's go ahead and use Excel to find that probability. However, let's remind ourselves that the command norm.dist will only give us the area to the left. Once again, we can use our knowledge a little bit about the areas under the curve in order to manipulate that. If we know the area to the left of 77 and it goes all the way, and we subtract the area to the left of 64, then we are left with the area in between 64 and 77. So you can see the Excel command that we have up above indicates that we should use just that formula. In other words, we're going to do norm.dist, putting in the 77 first, and then we'll do minus norm.dist, and this time we'll put in the 64. The mean and the standard deviation are the same in both instances. Let's actually input this in Excel and see it happen. Okay, now you can see that we typed in exactly as we said. And you can also see that we put in the 77 in the first norm.dist, which is the higher value, and we put in the 64 in the second one. So we always put in the value to the right first, and then we subtract the value to the left. Let's see what we get. So 0.469342 is approximately the area between 64 and 77. In other words, the percentage of women who meet the height requirement for the U.S. Air Force is approximately 46.93%. Let's go ahead and write that area under the curve. Okay, now let's say that the question went on to ask us, suppose there were 1,000 women trying to apply for the U.S. Air Force. What number of them do we expect to meet the height requirement? Well, we would simply take our 1,000 women and multiply by the proportion or the percentage of women who meet the height requirement, and that's what we would expect. So in this case, we would multiply 1,000 by 0.469342, and we would see that approximately 469 women would be expected to meet the height requirement out of 1,000. These problems that have been demonstrated in this video should help you when you try to work questions 9, 11, question 14 part A, and question 16 from your Random Variables Checkpoint 3. Good luck with your work.